Okay, thank you. Thanks for a great talk. I've not been concentrating on yours, so I need to get my head back in the zone. Okay, so uh, I was going to talk about the UK public health response to zoonotic infections and focus mostly on the most important recent zoonotic infection because there's so much to talk about with that. Um, as mentioned, I'm a neurologist. I head the brain infections group, and then I have some national roles. I'm the director of the Health Protection Research Unit, and then also the UK Academy of Medical Sciences. Um, and then finally, director of the Pandemic Institute. What I thought I'd do was talk about the Pandemic Institute and use that as a framework to talk about what the UK response to the pandemic. I'm going to focus mostly on the research response because that's what I was involved with. But actually, the one slide I've just remembered I didn't yet write was just the kind of summary of what we did well and less well in the UK compared to other parts of the world, because I think that's quite interesting. Anyway, so the Pandemic Institute, I think I mentioned yesterday, was launched in 2021 with a philanthropic donation based on our long history of work on emerging infections. We have got about 42 million pounds worth of research now among our researchers who are spread across the three universities in Liverpool. So our work goes all the way through from predicting what's coming, preparing for it, trying to prevent it becoming a pandemic, responding, and then helping society recover with obviously health and welfare impacts, but also business and economic impacts and policy work as well. And we have about 100 PIs, principal investigators, and postdocs, and then about a couple of hundred PhD students. So it's a big collection of people across Liverpool. So in terms of predicting, and we're bringing together people who've worked in these areas for quite a while, and then we're trying to apply it to protect us from emerging infections and future pandemic threats. So the kind of work that we've been doing in terms of predicting is looking at data that's out there and trying to use machine learning to predict what might come next. This is something that was published in Nature Comms a couple of years ago, using mammalian and viral traits to try and predict what's coming. And we work closely with the WHO Pandemic and Epidemic Intelligence Hub. The database we have, so it's called EID2, and this was set up about 10 years ago, well before the pandemic. And basically, it's a database of what we know about pathogens and the related animals, reservoirs that they come from. So we're actually expanding it now to try and include all the sequencing data that there is on all the pathogens out there, which is quite a big task. And then also include information about movements of people and animals. And I think, did I mention yesterday you get flight patterns of every individual on the planet? And there's an example of it. So that I think is a year's worth of people flying. So we think if you kind of can integrate those data and also data on movement of animals, livestock, etc., and then also the climate parameters that we've just been hearing about, this will become potentially a really powerful tool so that you can then predict what will come next. I mean, I say it will be a powerful tool. I guess it will. Like we talked about a bit yesterday, it's kind of interesting how much where you decide to spend your money, because I don't think there are yet good examples of any of this kind of prediction work really telling us. I mean, we've just heard some interesting things about CCHF virus, different strains, and other tick-borne viruses turning up in different places. I mean, all the sequencing data in the world, I don't think would have told us that Colorado tick virus is going to turn up in Turkey. Anyway, but I also mentioned about prediction and, how in some ways it's very easy, in some ways it's very hard. So when Zika broke out in Brazil, started some work there, and we were at a meeting a bit like this. And one of the postdocs stood up and said, we'd started our work, said, Professor Solomon, you predicted Zika as being a problem. This was brilliant foresight. I hadn't got a clue what he was talking about, because I didn't remember predicting anything really. So I didn't embarrass myself or him. But I did go and talk to him in the coffee break and said, what on earth are you talking about? And he said, well, yeah, you wrote in the Lancet a few years ago about Zika being a threat. And yeah, I did. But I mean, we published this paper about this whole massive list of pathogenic flaviviruses, including Zika. So like I said, it depends how you look at it. It's not hard to say shit's gonna happen. But exactly what's gonna happen where, I hardly think that was a great prediction of Zika in Brazil. We just said basically there's going to be trouble with other flaviviruses. So anyway, but here's one prediction we did get right. So West Nile virus, we were looking at climate change. This is work led by Matthew Bayliss, a colleague. And we were looking at the impacts of climate change on UK mosquitoes, and then also which UK mosquitoes might be able to transmit which pathogens. And we did predict that our West Nile virus might arrive and our mosquitoes could predict that could transmit them. And this was earlier this year, I think. So West Nile virus has been detected for the first time in the UK. So yeah, so the predictum work does have some benefit, I think. Cost benefit ratio, I'm kind of always interested in where's the best place to spend your buck. And I think clinical surveillance probably still is the most useful, but that's my bias because I'm a clinician. So we do have programs, though, in different parts of the world, working with colleagues there to strengthen clinical surveillance so that we do spot things that arrive as soon as they arrive or as soon as they emerge. And here, for example, in the Horn of Africa, we're working. This gentleman in a funny hat is a veterinary surgeon. They're always a bit odd, the vets. And he's doing programs looking at zoonotic reservoirs, looking at the animals to see what's out there, and that might therefore spread to humans. And I showed we have sort of similar networks in various places. Okay. Prevent is about the 100 Days mission, having drug treatments, diagnostic tests, and vaccines available within 100 days of a disease emergence, so that you can prevent it from becoming a pandemic. And there are various lists of priority pathogens, according to the WHO, NIAID, which was the US, and CEPI, which is a charity, and the UK Vaccine Network. And you can tell that this slide is out of date because one, NIAID, that green circle, you could basically just get rid of that altogether. The US has kind of given up on global public health, although they are interested in them if they are military threats. But certainly NIAID is basically imploded. And also the WHO blueprint has now been updated, and I think I've got a slide of that. But you can see everybody has their own list of priority pathogens, but some of them in the middle, everybody agrees is a priority, and CCHF and Lassa and Rift are well in there, as we've been hearing. So we in Liverpool, among the priority pathogens list, we've decided which are the ones we're focusing on. So we have our flagship pathogens programs, including SARS-CoV-2, CCHF, and I've been messaging people saying, I'm with Professor Erganel, some of our colleagues who are leading some of this work in Liverpool. Flu, because clearly avian flu is a threat. Mpox, we've done quite a lot of that. And then we have some of the other areas of interest, and then some of the other medium priority pathogens. But we're doing quite a lot of work. So there's Tom Fletcher, who you've worked with, who's leading the therapeutics program. Emily Adams leading the diagnostic work. And this is their new WHO list, 30 pathogens. And I think over half of them are actually contain hazard group 4 pathogens that need CL4 labs. And I think you don't have a research CL4 lab in Turkey. Do you have or am I wrong on that? I'll chat with you over coffee. Anyway, we're interested in this because in the UK we have a public health lab, but there's no university-led CL4 lab. So we're looking at that. And so antiviral drug development is clearly a key part of the 100 Days mission. We ran from Liverpool a program called Agile, which doesn't stand for anything. It's just the doctors who are leading it think they're very agile. And I guess they are. We did quite quickly respond and repurpose. So this was quite useful in the pandemic about prioritizing which drugs should be looked at and then looking at them. And then the other piece of drug development is trying to deal with the so-called valley of death. There are two valleys of death. One of them is going from preclinical to clinical studies. So you can show more or less anything in an animal model. I'm being a bit facetious, but you know, there are so many drugs that look great in a mouse model or a primate model, but then you put them in the clinical studies, and human studies are very expensive and hard to do, and the drugs fail. So we're trying to address that with some of these body on a chip technologies, also known as microphysiological systems. And I think we heard about some of those just now. They're ways of doing less animal work but using human tissues. So here's how they work. And there's various ones, but they're all human organoid models is one approach. But essentially, you're taking human tissue, be that lung tissue, growing it up in the test tube, and then you're saying, okay, this drug looks like it works really well in the primate model of our respiratory infection. Before doing a very expensive human study, let's just check the drug also works well in our human lung tissue model, because if it doesn't work in the lung tissue model with human lung cells, it's probably not going to work in humans, even if it worked in the primate. So that's the general idea, and it helps you decide which drugs to take forward into clinical trials. And then these are the kind of things that the agile guys do. So traditionally, you've got drug A, which you run against placebo. If it doesn't work out well, you then go on to drug B, and then you go on to drug C. So what these guys are doing is drugs A, B, and C in parallel against placebo. And this is what we did during the pandemic. But additionally, they're planning beyond the phase 1 studies, get the phase 2 and phase 3, get the whole thing planned so that if phase 1 works, you don't need to then wait and go to the regulator, et cetera, and you can progress straight to phase 2 and 3. And that's kind of what happened in the pandemic with the vaccine studies. So all the same regulatory stuff, but just a bit smarter about getting things through. The other thing we have in Liverpool is a first-in-human, a really good clinical trials facility, including the ability to do first-in-human studies. And then I don't think I've got the slide of the human challenge facility, which again allows us to deliberately infect people with mild versions of viruses or other bugs, and then study the disease right from the start. So really useful tools. Vaccines. So this was the COVID. Actually, that's not vaccines. This is vaccines. We have a strong vaccine development pipeline. This is just showing you for pneumococcus, going all the way through from the basic sero epidemiological studies to identify which isolates might be important through genomics, antigen discovery, screening, and then all the way through to phase 1, 2, and 3 studies. And we have a whole load of different drugs in the vaccine pipeline, including some, we have a vet school in Liverpool. So there's also some drug development on some of the veterinary drugs. The ones I am most interested in are the viruses. And in particular, we've got a really nice product for Zika that we've taken from the basic discovery phase all the way through to the phase 1 first in man studies, which we started in January 2022 and which are now completed. And Liverpool has a lot of, as well as the research, we have vaccine manufacturing facilities and vaccine manufacturers. Many of the big vaccine manufacturers are there. So our government, the former government, designated this as an area, a high potential opportunity area for vaccine manufacturing and development. The current government has unfortunately seems to have run out of money for anything. They've diverted a lot of funding to defence because of the geopolitical climate in which we live. But anyway, our city still is very strong in this area, and the regional mayor has an innovation plan to invest 5% of our local economy into our strong industries, which includes infection control. And this is a rather sad slide, actually, an old slide. A year ago, AZ, or 2 years ago, AstraZeneca were going to build this new vaccine facility. But the government changed, and the new government didn't think they could support it in the way the previous one did. So it's not happening. Anyway, let's move on to responding to emerging threats. And so we run out of Liverpool the ISERIC program, ISERIC, the UK ISERIC program, the International ISERIC program. ISERIC stands for International Severe Airborne and Emerging Infections Research Consortium. I've got all the right words there, maybe not in the right order. But what we did was right at the start of January, actually, when at the end of 2019, December, we were following this emerging threat in China. And in January, early in January, we decided to activate our emergency research protocols for this emerging threat, so that by the time the first cases came to the UK at the end of January, every hospital in the country was up and running with this national research protocol for emerging infections. So that's 348 sites feeding samples into the hubs, which then fed them all into Liverpool. So more than 300,000 hospitalized patients included in these studies. So we were able to weekly report to government on what was happening. We had some of the earliest reports of symptoms and complications, risk factors for severe disease, recognition of hospital-acquired infection, lots of nice papers, which is good for people's academic careers, and the universities, the funders like to see that. And also, importantly, really well-characterized samples from really well-characterized patients for some of the critically important discovery science, including on the human genomics, on the virus genetics, the human immune response, the post-hospital problems or long COVID, and then also the problems that COVID was causing in the brain. And that's some of the work that we led on in our group because of our interest in neurological disease. And in fact, right at the start of the pandemic, we wrote this kind of prediction paper, I don't know what you'd call it, but basically we were saying, based on what we know about other viruses, these are some of the things we predict COVID might do. And some of it we got right. Some of it I'm not sure, we didn't get it right. We just didn't really predict it. We didn't realize it would be such a problem. So direct viral infection of the brain across the blood-brain barrier doesn't happen that much in COVID, didn't happen. But we did see lots of patients with neurological problems, predominantly through this para-infectious, strong body inflammatory response, which then affected the brain. And also, we predicted a bit of vasculitis, but actually disruption of the blood, of the endothelium was a much bigger problem, and stroke was a much bigger problem than we might have expected. So these are some of the features of some of the earliest patients reported through this ISERIC study, including those with fatigue, confusion, headaches. So there was clearly neurological things going on. And we set up a national study of neurological and psychiatric disease caused by COVID, recruiting patients across the UK. And what we found, we then replicated with an international study through our Brain Infections Global Network. And so we already had the BI Global study, and we just basically put up a couple of tabs and a couple of research projects on COVID. And basically, this was quite fun because we collected nearly 2,000 patients from 83 studies across all of these countries. And these are the WHO regions. Those are the contributions of different centers. And what we saw both in the international network and also in the UK study was encephalopathy, so patients who were confused acutely, accounted for about half of the problems. Stroke was about a quarter, and like I said, that was more than we would have expected. And interestingly, the worst outcome was associated with stroke rather than the encephalopathy. So the encephalopathy was a transient confusion rather than a true encephalitis with virus in the brain and inflammation in the brain. So broadly speaking, in terms of the neuro disease, we think there are three things going on. Number one is the systemic inflammatory response, which then triggers a brain inflammatory response, even though there's not much virus there. Number two was this prothrombotic state. So the blood becomes thick and causes stroke. So as well as the vascular endothelium being disrupted, the blood is prone to stroke, and we saw strokes. And then thirdly, there's the direct viral infection across the blood-brain barrier into the brain, which was actually pretty rare. Just a bit more about the inflammatory disease. So this was a study we did relatively early on, showing upregulation of antiviral innate immunity, mostly interferon pathways, and then inflammatory pathways, and then also the procoagulatory pathways. And interestingly, I think what this shows is these are WHO severity groups. And I think what that shows you there is that the disease severity doesn't really seem to relate very much to your innate response. So in other words, everyone has a pretty similar innate response, and that doesn't have a big impact on outcome. 6 is the most severe disease, if I remember correctly. But the strong inflammatory response is associated with severe disease. You can see there, this one is much higher than this, and there are some p-values. And the coagulatory response is a bit of a mixed picture. We also did some work looking at brain injury and its persistence. And you can see here that brain injury continues at follow-up, despite the fact that the cytokine response calms down and the autoantibody response calms down. So there are some things causing ongoing mild neurological damage, as shown by the brain injury markers, neurofilament light chain and tau. So that kind of fits what we were talking about earlier. You know, there really is something going on in these patients with their long-term brain problems. But the important thing is that these actually do improve over time. But it does fit this idea that neuro injury is common and maybe is being driven by this strong pro-inflammatory process and this dysregulated host response. And then this was published, actually, it says 2024. I think the preprints were 24. The proper paper came out this year. And this again was looking at this post-hospitalization COVID cognitive deficits at 1 year. So it's not just in people's minds, it is in people's brains, if you like. There are markers, brain injury markers are up in the people who have ongoing brain fog. And if you do some imaging studies, you can actually see that their brain is damaged. They have smaller, it's the cingulate cortex is smaller. And we're only able to do these studies, these comparative studies, because of the UK Biobank, which is a brilliant study that was set up years ago, saying, let's just biobank lots of normal, healthy people. So we were able to compare these brains post-COVID with brains of people from pre-COVID, looking at the imaging, because of course you couldn't, if you didn't have all those pre-images, you couldn't do it because everybody's been infected with COVID by the time you get to do it. So all of this, I think, supports this idea that, and I think I showed this slide earlier, that basically we've improved diagnosis of brain infections by looking for the pathogen. But I think this last 20% we will never solve that by just looking for the pathogen in the nervous system, because people are getting an encephalopathy because they've got a systemic infection. And we've showed it for COVID, and we're now trying to show this outside COVID times, that other people who present with an encephalopathy and confusion, it maybe is because they're having a systemic and a brain response to a peripheral infection. Okay, let's move on. This is this man I told you about earlier, my patient. Seem to show a lot of pictures of my patients who don't do very well, but always shown with permission. So this is the guy that died from the AstraZeneca vaccine, causing blood clots. And what we showed, so these are some images of the blood clots. It was a syndrome of thrombosis associated with thrombocytopenia, low platelet counts. And what happens is the platelets, we think actually it was antibodies against platelet factor 4. So if you've got the Chaddox vaccine, some unfortunate people made antibodies against platelet factor 4. So it set up the clotting cascade. So their platelets dropped and they thrombosed in their brains. So we stopped using the vaccine it was only happening in older people. So we stopped it. And now it's not being used anywhere, I think. Okay, let's move on. So I spent a lot of time on that last pillar because we had some interesting data to share, but we will move on to talk about the respond pillar. So you may remember early in the pandemic, we were testing people who had symptoms, but it seemed to be that there were some people who had the virus and they didn't have symptoms. And there was a controversy, a question around, should we be testing everybody? Why don't we test everyone? We'll find people who have the virus and don't know about it, and we'll be able to quarantine them, and that will bring the disease under control. So in the UK, we did this test, this research project in Liverpool, offered mass testing to the whole population, and about I think in the end, about over half the population, I think 2/3, came along, got tested voluntarily. And of course, many of them did have asymptomatic infection. So we quarantined them and we got the circulation of virus right down. So the cases dropped by a fifth, and detection rose by a fifth, and hospitalization fell. Anyway, we showed that mass testing works, and it very quickly became national and international policy. And the other big program we did in Liverpool, as we were trying to get society going again, and again, this one was in the international news, was about showing how we could safely get big events going, big parties going, if we tested people beforehand and tracked them. And so we had the first dance weekend, and it was interesting actually. And again, we showed how you could safely do this kind of thing. And our ambition now is to do this kind of work. I mean, I think it was interesting. So at one point in the UK, as things were coming under control, coming towards the end, people were still doing home testing for COVID, and then they were self-isolating if they were positive. And I kind of thought, well, we're doing it for COVID. The government then said you don't need to do it anymore. But I kind of thought, well, I wonder if people will carry on. And also, we could do it for RSV and we could do it for influenza. So why aren't we, why don't we just carry on with this? People self-test and then work from home if they can, to keep these infections under control. It didn't really happen in the UK. I think here it probably potentially does happen a bit more. And, there's, I don't know, 7 of you wearing masks today, which I think usually means that you've got a bit of something and you think, I don't want to share it. This is my understanding. You can correct me later. Whereas, and I think potentially in this part of the world, people will test, and if they're positive, they'll stay at home if they can. But in the UK, all of this is gone. So it's interesting. And we're thinking, it would make sense if we could have this kind of attitude. If we did what we did in COVID, if we did that every winter, then people who could stay at home stayed at home, work from home. Our hospitals wouldn't fill up with patients every winter, and every winter we have a bed crisis and we have to cancel operations. So we want to do some research around this to one, so that we can get benefits every winter, but also so that we are ready for the next pandemic. Because the research that we didn't do very well in the pandemic was around social interventions, social distancing measures. We still don't know. I don't think you know. I mean, people are wearing their masks and maybe they're testing at home, but we don't know if Crimean Congo hemorrhagic fever, there was an outbreak here in Hong Kong or in Turkey. Maybe you do know in Turkey. We wouldn't know. Let's say it was becoming respiratory spread. Should we watch? Which social measures should we do? Should we close the school? If avian flu happens, which is quite possible, what do we do? Do we lock down? Do we close the schools? Do we close public transport? Should we be closing the pubs? Um, I don't know the answer to those questions, and I'm not sure anybody does. And we've been through a pandemic, and we still don't even really know how to do that kind of research. Should we be doing cluster randomized controlled trials? During influenza 2009, you did do them in Hong Kong, cluster RCTs for keeping people at home. When we talked to our government early in the pandemic about cluster randomized controlled trials, and these are trials where you're not randomizing individuals, you're randomizing clusters. You're saying, should we close schools or should we close factories? I tell you what, in half the country, we'll close schools. In the other half, we'll close factories, and we'll see which is better. That's a cluster randomized controlled trial. Our politicians didn't think that our public could cope with cluster RCTs, so they wouldn't allow us to do it. So we still don't know. All the debate over hand washing and wearing masks. At one point, we were told, no, wearing masks makes things worse because it catches the virus, and then you touch it when you're taking the mask off and you pass it on. So for me, this is a big space where we need to do stuff. As you can tell, I'm slightly passionate about it. Let's move on. We are able as an institute, because I have funding, and a lot of it's from philanthropic donors, so I can use it flexibly. We're able to very quickly respond. So when Mpox emerged as a problem, we were able to do studies across the whole portfolio and help bring Mpox rapidly under control in the UK. We've got, again, we put out a call when avian flu looked like it was, when it looked like D-Day had arrived. We rapidly funded more work on avian flu in partnership with our UK Health Security Agency. We do, I mean, I'm slagging off the government. We do have good relations with the government, including the current government, and they do, we do advise on policy, and I guess some of it they listen to and some of it they don't. And then also we do quite a bit of international policy work as well. Quite a lot of time explaining to the public what we're doing and why, and that's an important part of the work of the Pandemic Institute. We have strong partnerships locally with our local commercial partners, and then also nationally. And we have in Liverpool or most of the infrastructure we need, including containment level 3 labs, in vitro, in vivo, also a mosquito containment level 3 lab, there are not many of those. And we have future plans. We do quite a lot of training and capacity building, both in the UK and internationally. And we are part of the UK Pandemic Science Network, which brings together all the leading players working in this space. This was our annual meeting, a jolly affair. And then also we're working in partnership with most of the major international players in this space. But if you look carefully, you'll see that although we're working with the Chinese CDC, there's a gap, and we're working with Singapore, there's a bit of a gap here. And that's part of the reason why I'm here. I'm here for you guys. I'm here for the talk. Part of the reason why I'm not here as much as I should be is because we're also this week launching this new partnership between the Pandemic Institute in Liverpool and the University of Hong Kong, Chinese University of Hong Kong, and Hong Kong Poly U. And so this came about because in November 2024, I came along to the Shaw Prize. Put your hand up if you've heard of the Shaw Prize. Okay. Put your hand up if you've heard of the Nobel Prizes. Okay. So the Shaw Prize, we're told, is the Nobel Prize of Asia, except because it's Asia, it's bigger and better. There's more money. And this it is this you get more money for the Shaw Prize than the Nobel Prize. And also the ceremony is fantastic. So I went to it last year, and it's like the Oscars. It's brilliant. It's a scientific ceremony, but the music, the lights, amazing. That's Raymond Shaw, who is Raymond Chan, who is the director of the whole program. That was last year's winner of the prize for medicine. Tian, her name is, and we overlapped in Oxford, so that was quite fun being here for that. And the Shaw Prize again happened this week. So when I was here in 2020 last year, I met with lots of people at the various universities, and we thought there was certainly interest in this program working together. Anyone know who that is? Who is it? This one in the middle. Oh, you're not getting the mouse is not working. The guy Ewan, yeah, Professor Ewan, who's a great man, great person. So I came back in May of this year. We talked to the people at the Shaw Foundation, connected again with the research partners. And so I just thought you might, if there's any interest, I put up this slide of the projects we're doing. And you can see there a range of projects on important emerging pathogens. And the way it works is we have a UK investigator and a Hong Kong investigator co-leading the project. Anyway, they're all working hard on that whilst I'm having fun here with you guys. So that's me done. Do come and join us in Liverpool, especially if you've got a free place. And thank you very much. Those are my socials. I don't know if any of you have heard of Twitter. I think it's called X now. Do you have it in here? Or is it banned here? You can use it. Instagram. Yeah. TikTok. No, you can't TikTok. But I thought TikTok comes from China. No? That's one of the anomalies. That's the craziness of working in Hong Kong. But Instagram and Facebook, I think I'm on all of them. Thank you very much.